G'day everyone. In today's video, we're just going to look at composite functions. And so what we mean by that is a function inside of a function. Before we sort of get to the nitty gritty of it, let's just have a think about sort of, what we're sort of talking about here. And I find the best way to think about these things is to think of like two boxes, right? So in our first box, it subtracts 2 from a number. And in the second box, it takes the square root of a number. So I've got sort of two boxes, and we can like put numbers into this first box, whatever numbers you want, and it will subtract 2 from it, and it will pop something out. Some number will come out of this box. And then we've got this other box, and you put a number into it, and it will take the square root of that number, and it will pop another number out the back. Okay, so that's pretty obvious. And we can, obviously if you put x into the first box, then what that box will produce is x minus 2, and that'll sort of pop that out. So that's, if we call that, I'll call that function, let's call that function g of x there. So we're going to call that function g of x. It subtracts 2 from whatever number you put inside it. Let's have a look at the second one. Let's have a look at, let's call this one f of x, and f of x is root x. And so what that function is, if you put x into there, then it takes the square root of it and pumps it out. And so what we've got is we've got this machine, and whatever comes out of the g of x machine, it goes out, and then it goes straight into the second machine. So a composite function where it goes through two machines, one after the other. Okay. So let's have a think about this, right? So let's say if we put the number 10. Okay, we put the number 10 into this machine. It goes into there. What comes out? The number 8 comes out of the machine. And then this number 8 goes into this next machine. This machine takes the square root of that machine, and then it becomes the square root of 8 at the end. Okay, so that'll be 2 root 2, whatever. And so you've got this number 10 that's gone into the first machine, and then it's gone into the second machine. And that's all well and good. But we can break this machine. It doesn't always work. And so let's take another number. Let's take the number 1, for example, if we put 1 into this machine. So if 1 goes into the machine, what comes out of this first machine? 1 take away 2, negative 1 will come out of this machine. And then if we go to plug this, negative 1 then goes into the second machine, and then we get the square root of negative 1, which is not a real value. And so we've broken the machine now. These machines don't always work. So a composite function doesn't always exist. You can't always do this. It doesn't work for everything. And so we just need to do some checks. When we sort of create these functions, we need to do some checks. And what that check is the following. So whatever comes out of the machine here must be a subset. And let me do this in different color. What haven't I used yet? Let's go back to black then. Okay, so whatever comes out of the machine here must be a subset. This little symbol I'm doing, that will sort of look a bit of like a C with a line underneath it, must be a subset of whatever is allowed to go inside here. In other words, everything that's allowed to go into this machine here, all the legal things, not illegal, legal things that can go into that machine, if we only allow things that come out of here to go into that machine, then it will work. Okay, so what does that mean? Well, what it means is that basically the range of this second function, so the range of g, as long as that is a subset, so equal to or smaller than all the values that go into f of x. And what are the values that go into f of x? That's the domain of f. So as long as that is true, then the machine will work. Okay, so as long as the values that come out of g, as long as they are equal to or smaller than the range of values that can go into the function of the domain of f, this will work. Hopefully that makes sense. And what it looks like when it comes out, you've probably already guessed, is this function is like firstly g of x, and what happens secondly is f of x. And so we call this function f of g of x. In other words, it goes into g first, then we find the value of g, and then it goes into f second. And so we call this f of g of x. It's also known as fog, fg of x, like that, fog of x with like a little o, f of g of x. And so that means g of x is effectively inside of f of x. And hopefully that makes sense. And so in this case here, what does that actually look like? Well, g of x is inside of f of x. And so instead of f of x, instead of writing x there, we write x minus 2. So the f of g of x here would be x take away 2. That would be what that function looks like. In other words, x minus 2 is inside of f of x. If we've replaced x with x minus 2. So that's the function there. So what we can do, we can sort of go back and have a look at it. It's like, well, if this function is broken, right? So this machine doesn't work, and just let me find my eraser. So if this machine doesn't work for some values, let's have a think about what values is it broken for? Which can we fix up this machine so that we can restrict what goes inside it so that, to make sure it works? Okay, so what can we do to this machine? So let's have a think about what numbers break this machine. Well, we don't want anything negative going into the machine, all right? So we think about this and we go, well, the numbers, we really want the numbers going in to be greater or equal to 0. We can't let anything less than 0 to go into this machine. All right, and so therefore, we can't have anything coming out of x minus 2 that will be greater than 0, okay? And so if we say to ourselves, well, if we say that x must be greater or equal to 2, for what we put into the first machine, let's have a think about it. If x is greater or equal to 2 that we put into the machine, and then it takes away 2, then we will end up with values going into the machine here that will be greater or equal to 0, and this will work. And so what we can actually do is we can actually restrict the domain of that g of x function to force this machine to work. And so we don't get any of these nasty values going in that will screw everything up. So we can actually, what we call it is restrict the domain of g to make this thing work, make the function work. Hopefully that makes sense. Let's do an actual proper example where we sort of have a look at what what that looks like in real life. So let's do that. I'll go back to here, and so let's look at two functions. Let's look at fx. We sort of just did an example, to be honest. That was well and truly one. And let's do g of x 1 over x minus 2. Okay, and so we'll just have a look at whether these composite functions work. Okay, and I'll just save a bit of space. I'll just come over here in blue. Okay, and so let's have a look at it. Let's see, does f of g exist? Okay, so f of g of x, let's have a look. Does this exist? Okay, so for f of g of x to exist, what we need the range of g to be a subset of the domain of f. Okay, so that's what we need for this thing to exist. So let's have a look at it. What is the range of g? Range of g. So looking at g, the range of g, what will come out of that? Let's have a quick sketch of the graph. So x minus 2, so it's going to have asymptote at 2, and we're going to have sort of lines coming like that and like that. And so what is the range of this function? Well, it's going to be r. All values is going to come out of there except for 0. So that would be my range of g. What's my domain of f? For the domain of f, we're allowed to put any x value in there, so that is r. Okay, domain of f is r. Does this satisfy our need here that the range of g must be a subset of the domain of f? So the range of g was r not including 0, and the domain of f was all real values, and yes, that is a subset of the domain of f. We're allowed to put anything inside f. It has no problems whatsoever. And so, yes, that composite function exists. F of g exists. That is perfectly fine. So what would it be? Let's have a look at that. So f of g of x. So g of x goes inside of f of x. And so we write out f of x. We write f 2x minus 1. But instead of writing x, we're writing 1 over x minus 2 minus 1. So I've written g of x inside of f of x. And if I just clean that up, that's just 2 over x minus 2 minus 1, which is just another hyperbola. Okay, so that's it. That's the composite function. We've tested to see whether it exists. All good. Let's try the other side of the coin. Let's try to see whether g of f of x exists. Okay, so we need the range of f So the range of the inside function must be a subset of the domain of the outside function, the domain of G. So let's have a look at it. What is the range of f? Where is our f? The range of f, that's a linear function that just goes on forever. So that is just r. So the range of f is r. And I'll see, am I going to squeeze this in? Write it here. Just got there, I think. And we want the domain of G. The domain of G, we go back up to this graph up here. The domain of G is all real values, but not 2. Okay, so it can't be equal to 2. That's the maximal domain of that function. So what do we want? We want the range of f, this, to be a subset of this. Does that fit inside that? No, it doesn't. Okay, so it almost does, but not quite. It doesn't quite fit in there because the range of f allows a value of 2, but the domain of G does not allow a value of 2. So this does not exist. So the composite function does not exist. Okay, and so that's sort of how it works. We need to test that. If we went back and we wanted to force this thing to work, we could, this isn't part of sort of what the question, but if we wanted to go back and force it to work, then we would go back and say, well, we want the range of f to not include 2. If the range of f can't include 2, that means f of x, not equal to 2. So therefore 2x minus 1 can't be equal to 2. And then 2x can't be equal to 3. X cannot be equal to 3 on 2. And so if we restricted the domain of f to be, if we had the domain of f to be all real values and not 3 over 2, then that machine would then work and the composite function would work. But as it stands, without that restriction there, the composite function does not exist, and so we can't go any further. Hope that makes sense. I'll see you in the next video.